Wow. Cảm nhận interest. Wow. Tại sao cảm nhận đó? Well, anyway, let's get started. All right, hi, welcome. And today we're going to do a just code section, and the just code is a moniker that I'll be used forward to do just some code streaming, and it will be unedited, just work on a specific topic, and maybe in the future I would create a condensed version, add some do some editing of the video, and then publish a more concise version to teach or share a specific knowledge that you get from this stream, right? But because of my schedule, I might not able to do it in time, or or maybe at all. So there will be still value of just looking into watching these just code videos, and hopefully it will make it beneficial or useful to you. And but with that get out of the way, let's get to today's topic. So today, what I'm going to do is something about the function overload in TypeScript. So the issue is when we're doing function, when you're writing a function in TypeScript, which needs different kind of parameters dynamically. So meaning you need to do some basically judgment. Excuse me, it was way too low. I can't hear myself. Okay, let's just do this. Oh, it's still very loud. Oh, okay, now it's much better. Okay, anyway, so when you need to make a function with a argument that you require some logic, for example, like what you're seeing here, it needs different kind of input, or accept different kind of input, and also it would produce different kind of output. There are basically two ways to do it. You can do some function type level programming, or using type inference and doing some ternary operations, using the extends keyword to do things, or you can use function overloads. So in function overloads is something very common in the in some languages, like in Java, C#, but it's also missing in some other language, like say in Rust. So, but it is easy to do, right? And in TypeScript, at the beginning of TypeScript, is very common to use function overloads to describe different kind of input that you would expect. But then later on, when the TypeScript itself become more expressive, then people start using type level programming to do to kind of achieve the same or similar result. And here is something that I'm working on in Just Web, and I'm running into some problem, and I'll go over the problem in a minute. And the main purpose of this video is see if I can solve that problem. So without further ado, let's get started. So first, let's understand the problem or what I'm trying to do here. So what you see here again is the is some code in Just Web. I'm working on the 4.0 version of it. I want to finish it this weekend and release it. And as I'm working on it, this is a code inside the states library. And the library internally, it uses immer, and it has this create state. It's a simple state management, and which have a set function. So you can see down here, there's return a value, have a set, have an onChange function, and have a reset function. So in 4.0, I try to bring some parity to the, or basically beef up the set command, this method, so that it is more powerful and useful. So one of the thing is it accepts the nothing value from the immer. So for those who you don't know, in immer, you can in the produce function, you can pass in, let's see if I can show you over here. Yeah, like over here. So there are multiple ways to use the produce function, and I have not yet worked on the support all of the functionalities that produce provide. But one of the way to use it is pass in a function. So when you produce, when you call produce, you can pass in the previous the value, and then a recipe function, which will generate the result. So to just demonstrate what that means is you will receive a draft, and then with that draft value, you can either return, say just assuming it is a number, you can draft +1, which return a value, return a new function. So return a new value from that function, and that value we will use as the new value. You can also modify it in place. Say it is an object with an A property, you can set A to true, right? And return that. Of course, when you're doing this, you have to put a parent around it to make it work. So like this, it will update the state in place, and which immer use the ES6 proxy to keep track of the changes and do that for you, so you don't have to do the immutable way all the time using the spread operator to compose the object and that kind of thing. So it is pretty convenient and pretty nice. But one thing is when it have this syntax, is missing one key functionality, which is what if I want to set the value to undefined, or basically to clear the value. So because you cannot just return undefined, because when for a JavaScript function, let's say like this, while it is not returning anything explicitly, implicitly JavaScript will just get a undefined, at the caller. The caller will receive the undefined value. So this is really the same as return undefined, right? So the produce function cannot tell that you are returning undefined explicitly, so that meaning you want to clear the function, or it's just a implicit thing that JavaScript provide. So in order to support that, Emma have this nothing instance that it be used to indicate that you want to set the value to undefined, or to quote unquote nothing. The way it implements it is using a class. This guy is actually a class. So it is using a class to create some nominal typed construct, right? So another way is say in Type Plus, I have the brand and flavor mechanism to do nominal type thing. But in Emma, it just create a new class instance. So that's fine, right? And so that's how it handle the clearing or setting to undefined case. So that is one of the things that I want to support in version 4.0. So this is what I get so far. So this get state type is the type of the set function. Okay. So I have already made a few iteration of it to kind of simplify it to this state. So there is this updater and async updater. So the Emma, the produce function of Emma also support async call. So basically returning a promise, and it will just also work, right? So I support both. Right, and I have state.spec. I have all the tests I've done over here. You can see there's a whole bunch of tests over here to make sure the case is supported and working fine. So now, with that done, originally I thought I'm done, I'm good. But then when I look at the project, right, in other places, when I start using it in other functions within the same library, it starts failing over here. So you can see there's a failure over here. In the header, there's also some failure over here. And also in the test over here in the header, there's some error. So what's wrong, right? What's wrong? Because over here I already have it tested, right? So to make sure that you follow, let me quickly go over all the test cases. So these we don't worry about. The key things over here in the set function. So we can set the value directly. So that take care of that's this case. Right, and then yeah. And then it can accept undefined. So this is one interesting case that when it is undefined, I want to return the type, want to return number undefined, right? But if the type itself does not support undefined, right? Say for the type is like this, or maybe I just get rid of it. Then the type you can see over here is well, actually let's do the v over here. So the value is just a number, right? Just the type of the value that you put in. So with that, since the type itself is just a number, the undefined should not be a valid input, right? So I want to capture that. So that's why you see this on the implementation side. You see this undefined extend t, and then if that is true, then I would do this instead of I do this. And over here, that's where I because of the t, I'll accept the undefined over here. You can see that this is almost the same. The only difference is that this guy, right, is the type of undefined. So let me undo this and then return the case that return nothing. Maybe I don't have it named correctly. Yeah. Oh, here, accept nothing. So this is the case that it accepts nothing. And then also there is this function that the function that returns nothing, right? So both of the case that will work for the case that is undefined, but if I take it out, you can see that this is wrong. And the same thing over here, right? If I take this out, this is wrong, right? So it gives a good user experience to whoever using this code. Right, so that's what this is. And if you you are curious that, oh, how about the return type, right? So that's where it is. So get it back over here, make this a little bit bigger. So you can see that this code itself internally do that check, right? If undefined extend t, then it will say it include this type of nothing. If not, it will be that, right? So that's what it is. So I close it. So let me go back over here. Right, so the other case are just the basic cases. So you can take a look at it. You can pause the video. Actually, let me expand it so you can see, right? Just the value, accept undefined case, accept the nothing, and accept a function that return a value, accept the function that is changing the value in place, and return nothing, and then the async variant of the same thing. So this returning a promise, doing async returning nothing, changing things in place, and also the async returning nothing. Right. So I have all these tests and all these are working. Then the question is why this doesn't work. Right. So that's what I'm going to investigate a little bit now and see if I can find a solution. So the handler over here, I have set it to the updater and the async updater, because this is the store function. So this is creating a store instead of creating a state. The difference is in the store, it also it has this update function and have this set function. To be honest, this one I might forget about it, because now with the states improved to have the set to handle all those cases. My video dies. Give me a second. Oh. Let's see if this fixes it or not. Nope, still not. I saw it just came. All right, I hope that works. All right. Okay, yeah, it's a annoying thing that it's an issue with the Apple Cam. I'm using the Apple Cam from Elgato, and their service on the Windows system keep crashing. I have reported the instance to them, and they are still working on it. Haven't figured out why it is failing. So what I need to do is to restart the service. It's very annoying. After it runs a while, it just dies by itself. So where am I? So back to here. Yeah, so for that function, since for the store, originally I created that to support, to let's put it side by side, right? To support the update function. Originally, this doesn't have an update function, this state, and the set function is only accepting the value, so it doesn't have allow you to put in a handler to do the update in place and that kind of thing. So that's the additional things that set provide in the store, right? But now with this updated, with this state updated, I might not even need the store anymore. So I might get this whole thing, just forget about it. But I can't say the same for this, right? This is a adder function. So what this does is it adds a add function, the add entry function to the to either the state, the store, or the registry. The registry is another thing that provides additional information or additional functionality. So you can see over here with the add function that's being added, you can just call this to add multiple entries to the store. And and for this one, it will add multiple entries to the registry. So that's how it works. So these also have the type error. So I would need to figure out what's going on over here. So you can see that here it is saying this expression is not callable. Okay, so just spell it out. It's each member of the union type. So you can see that this whole thing all the way to here, right? So this is one, and then this is the other one. Basically is saying these two, right? These two things. It's saying this, they have signatures, but none of those signatures are compatible with each other. And then because of that, it say the function is not, this expression is not callable. But the interesting thing is you can see that it is callable over here by itself. It's just that when it is on the second higher level, because back to here, because over here, this store right? It is a second, how do I put it? Is the generic on top of a generic, right? Because this is a function to add a new thing to the existing object, either a registry or a store or a state, which itself is also generic. Right, so with that, it was doing this, and then this code, the TypeScript code, is trying to resolve the code a little bit differently than when I am creating a concrete state and use it directly over here. And essentially, it is the same reason over here. So you can see that it's the same error. This expression is not callable. So if I'm able to fix this, I probably should able to fix the other thing because it's the same thing. So back to the type. No, over here. Hold on a second. Did I? Yeah, it is running. Okay. So you can see that these two union, the only difference is really this have this type of nothing, right? And that's why it needs this undefined extend t. And besides that, it is exactly the same. Originally, this actually looks a lot more different, have more function. This one have 4 different overloads, while this guy have 2 overloads. But I have simplified it into just one single function signature, and it's not even a overload right now, so to speak, because this is just a union type, right, of 2 different types. So let's see. Right, let's move this guy over here on the right hand side. So pay attention that this is still red over here, and see if I can fix it. The first thing is, yeah, it looks a little bit weird to have this syntax, right? Have a object syntax to include a single function signature. So if let's first simplify it by, say, removing that to something like this, and you can see that that doesn't work. Right, let's see why it does not work. So this does close correctly. And this does close correctly, but it doesn't. Very likely the reason is because of this type that I have over here. So if I have, oh, hold on a second, why there is some weird, oh no, hold on a second. This is when I change it to that, that would be an arrow function syntax. Okay, now this works. Right, so let's close this, make sure that this looks okay. But on the right hand side, you can see the error. Oh, come on. You can see the error is still the same. Well, as kind of expected, because we have not really do anything. We just changing the way that we define the same thing, right, to make it looks a little bit nicer. So now the difference, the other thing is really the only difference between these two is this type of nothing. So for the sake of the argument, let's see if I remove it. So you can see that once I remove it, this error is gone. Right, this is working. And let's see the other one. So this is this also still have problem, but the place over here, this is fixed. Right, this we can deal with it in a little bit. Right, so over here, this this guy, and also this push function is wrong. That is probably likely because of this is wrong. So I don't worry too much about it at this moment, right? And then over here, I have this nothing as an error now because we took it up. Right, so just again for the sake of the argument, let's even remove this. Right, so then with that, this error still bad. Let's see. Let me actually do this. Let me copy it, make a copy of it, and just create, just use this definition for now, and fix the error function. So make sure that we have a clean working environment, because if this bugs me a little bit, or these errors, because with this error, I cannot validate that the whole thing would work after I say use this syntax. So what I'm thinking right now is say, okay, let me for the time being, maybe because of the limitation of TypeScript, or I'm not able to figure it out yet, let me not supporting this case for the time being. Right, and well, actually I won't do it like that. I won't make it a skip, and then unfortunately I would comment this out internally because it's a TypeScript thing, right? Well, of course I can cast this to as any, but that would make it very hard to figure out what I want to test. So I would comment it out, mark it as a skip for now. Right, so let's work with this simpler implementation first to see if we can fix everything. Then we will try to add the is empty back. So then down here, I don't want to miss that. So type of nothing to make sure that I still have that keep track of. So this is the type. So by the way, also for those you don't know why it is done like this, it's kind of, when you first look at it, it's kind of weird, right? Because this is a type, it's a generic type, right? It's a set state with a generic type T, and then you have another additional one over here, the type V over here. So because the reason is this type V is internal to these functions. So when you are using this type, this set state T over here, you can see that this create state, it doesn't mention anything about the V, because the value is what will be inferred or what will be declared inside the function when you're using that function. So you can think of this, get rid of this VT, because right now we have this copy over here, so we can just go ahead and make the change, right? Doing it like this, and then here the issue is we will say, oh, type of value, right? To do that, so yeah, so that is kind of another way to do it, right? So to get rid of the V, but I was adding it there in this iteration because I try to extract it out to make it a little bit easier to read in this logic. So, but either way is fine. So let me just keep it like this for now, and see if I can figure out the other problems that I have over here. So make sure that everything is fine. So this state, so now this is wrong, So what happened? So this, so you can see that this has issue. All right, so that's why I put it out the V type. So here, this is getting a number, and it is a number because this, it say the type can be either one of these three. Right, because we lost the we removed the generic type V, so the function, the signature of the function now shows you can have either one of these, and because of that, the type of value here also resolved to these three things. So the way that we can verify it is, say we comment that out, and you can see the R, the return value of that is this free value, free types union. That is not what we want, right? So that is why we have to get this back, add this type over here. So now you can see that this is properly resolved to the type that you put in when you're using that function. And so, well, let me also just in case put that over here to show you what's the difference. So you can see that this indicate the type of the function that you put in, which is a function returning a promise of number. Right, so that's the difference. So now this, make sure it's working. So that's one key takeaway when you are working on type level programming, is that the testing, right, the unit test that you put in is really critical, because for one, TypeScript is not sound. Is by default, by design, is not sound. That's not one of the highest design goal of TypeScript. So there are a lot of muddy water within the type system, right? So if you don't have all these types spelled out, when you're making some change, maybe you might think some very innocent change, it could actually screw up the type. Right, so you can see over here, I'm not even just calling and await over here, because this is a promise, so I assume the result is promise, so I do a wait and want to get the result back, right? Instead, I actually get the value back first to make sure that it is a promise, and then I wait and get the value. Right, to make sure that I'm not accidentally, this type is not resolving to just number. I want to make sure that it resolves to a promise of number. Right, that's how detailed you need to get to when you are working on types. So let's see. Let me give me a second. Okay, so let's continue. So that's why we will need this over here. So you can see that that is working. So now let's see what's up over here. So this signature is not comparable with its implementation. So okay. So over here you can see that this error is using function overloads, right? Oh, by the way, one of the key benefits of function overloads is that it is very clear of what are the different use cases, and with function overloads you can add different comments, right, the JS doc to each of the overloads. So let's say back over here, right, so with this guy, right, with this guy, I can, let's say, get a 2, right, and I can add a comment for this overload. Well, actually, this is not really an overload, right? It's an expression, but I can still do the same thing to separate it and give different information, provide different information to the consumer. Right, so that's I would encourage everyone to do. But you can see that I don't even have it myself. So you can see the effect at a spec over here. If I'm doing this, when by default, when this is just a overload with all this, you will see that they are all available. All this the comments is available over here. And for this guy specifically, because it's a store of an array like this, so if I do something else over here, you can see that this is using that comment. But if I put something other thing over here, this will still get this guy, right, because it will resolve correctly. But anyway, if I able to have one comment that works for everything, yeah, that's okay too, but you have that option. So let's take a look at what we got over here. So we have this registry way of doing thing, and it was saying it's not compatible with the implementation signature. And here, this one, the last one, is the implementation signature. And that signature is not really being used to the consuming side. So you can see that there are 3 overloads over here, while I have 4 things defined over here. The last one is the implementations, the actual implementation. The first 3 is the function type overloads. So these 3 are the ones that are going to show to the consumer. So on that, that is another thing that is kind of annoying. If I can make it work, that's okay, that's great, because then inside the implementation, I would able to utilize TypeScript to help me when I'm writing my implementation. Okay. However, I can also set this to any, right? And so you can see that that error is gone. So let's say, yeah, I think I know why, because I removed the set over here. So there you go, right? Because this only get the get, while this we require the get and set. That's what the problem is. So actually that solved the problem. So if I can do that, then that's okay, right? If not, sometimes I would have to, mark this as any or mark this with some other type so that it will go on. And I'm comfortable to do that because I have tests, right? I have all of these tests available to make sure that the thing is working as expected. Okay, so now here, here is some problem, right? There's one error over here. Let's see if it have other errors. So others looks okay. Right now I'm just looking at the type error, so if there's a type error, it just show on the VS Code, so I don't really need to run JS or anything to make sure things is good. So that's what type gives you. So seems like right now this is the only thing left. So is the header. This guy, So that is, I think that is one of the things that I have changed. So it's because of this. What do I get over here now? It's still a writable draft. So so header of a store, right? Is the store is a store of string array, so it's supposed to get in here. And then so the second function is the add entry, right? Or the basically the handler. I probably rename it. Okay. Oh, so rename it as the handler. And then here the handler takes this draft A, and then the entry is array value A, supposedly. But it seems like that is not the case, because the array right now is a writable draft of what is a record and of key of. It seems like it get to the first case. So I can test that. Yeah, you can see that if once I comment it out, that works, right? And if I do this, that doesn't work. So meaning the inference of TypeScript couldn't detect that this is a record of T. So very likely I need to adjust this. Adjust this type. Because for one, right now they are exactly the same. So what if I say this is R? Okay, that would make that work over here, while it have this failure. Let's just call this correctly. This is a registry. This, it get the T as a unknown type. While over here, the T is the string value, and it's an object. So it's not able to infer that T. This got to any type. Let's just in case, let's roll with it. Let's change all this to that. Because the reason originally I do the pig is because within this function, you can see that I only need the set function, and then the handler, I think the handler needs a get function. But maybe not, maybe I don't even need to. I only really need the set function. So that's probably some artifact that left over that I didn't clean up. So let's say I remove this. Let's say get this to any. That wouldn't work. Well, this is type of any. Yes, I know, but I don't care. I get rid of this. and that still wouldn't work. The reason, I guess, is because it is about type resolution. Because right now I'm picking only that specific function out, and that specific function is actually shared, actually including the get function. It's the same function across the types now. Right? It used to be different, right? Remember, I was making changes to this set function, and now they somehow they get to the same type. So because of that, when it tries to do the resolution, it gets to resolve to the same thing, and that's mess up TypeScript. So in order to help TypeScript to make it easier to identify the actual type, I would change that to just the store, just to this, and then this just to store any. Right, like that, which I know will be a problem. I probably will need to undo all this in a moment. But now, for now, this is working. Although here there's a problem, right? Because this haven't changed. Well, let me just undo this for a moment, because if possible, I don't want to use the any type. Right, so now with all this in, and so I would just get back to S. This is S, so that still works fine. Okay. So the issue is back to now. This entry is of type unknown, while here is clearly it is not. Right, this T. So to fix this, very likely I need to do something similar. No, I can't. So the entry type is, I would need to specify, I need to make sure that I knows what's the type of the entry when this function is called. So I can't do it over here in the return value. Unless there is a way for me to extract the type T out of the registry. If not, I can't do it. I can utilize the keys function, but that's really hacky. What can I do? And my cam dies again. Give me a second. Hopefully that will fix it. All right. So let me just try. So the thing is with at the type level programming, at least in my experience, a lot of times is some try and error. It's not. It's I would say it's very difficult to do type level programming, because still now that the because TypeScript is not sound, there is a lot of things that you have to try to see if it works, right? For simple things, yes, you can have follow certain logic to say, oh, I want a record, then I just use a record type, right? And for simple things like, say, the undefined is extend undefined, so this kind of things is simple to do. Right, and a lot of people writing TypeScript, that's kind of where they stopped, right? And which is okay, which is actually a good thing if that's all you need, right? If that's all you need, you can stop there, then that's good. But if you want to go any deeper, it's a whole different ballgame. So so over here now, let's see what can we get, right? So we get the type R, we can get the call the get function and get return type of that guy. So you can see that this get the record. So return type of this, that should give me the same thing for the record T. And then this will be get the list function and then get the array value of that guy. Let's see. Oh, the return type too. And then it will be the same thing for this T. It's horrible. I know it's horrible, but let's see if that fixed the problem. Okay, so add spec over here. Yes, it fixed it. So now you can see that here, this is properly inferred to key and value, right? And all of this pass, right? Except this guy. This guy is properly is the same thing. I will just need to get this to R. Right, so this is any, I don't really care what's in it, because I am going to extract the hell out of it from your input. Like that. Okay, that error goes away, and then here this guy is the store. of any, I don't care. That okay, this still have a problem. So now this cannot be because of this. This is a registry and all that. Now that works well because the reason is over here in the Hold on a second. Where is my? Give me a second. Oh. Damn it. Give me a second. Annoying. Right? Because the type here, let me change the color. What am I doing? This over here, it's okay. This over here, it is a store. I'm expecting a store. Oh no. Yeah. So that guy, no, actually here, this guy, I am expecting a store, right? This adder, because of, well, no, this store is the actual store. So that's why this now all doesn't work, because I need to pass this in down there. So that types need to match. So I need to get rid of all this, right? Which I would say I don't want to, because back to the solid principles that your function, right, is this is the ISP, the interface segregation principle, that you should only require ask for what you need, right? So in this case, I know I really only need the set function and get function, or in that class, or in that object. So I want to declare just that. So in case in the future, if you have another thing that happens to have the same signature of the get, this function will work, right? So but there are some difficulties right now over here, so I'm going to change that to live with that for now. So back again. Okay, so back to here. So now at least it is working, right? We can further improve the types along the way. Right, so let's see, what do we get over here? So this is create a store record X. So it is the same problem over here. Why I don't have that? Very likely because I don't have the test for that. Yep, I have the test for the push and unshift, but I didn't have a test for a store which store a record. So that's why there's no problem over here. That's why there is a problem here. I probably should have also create a type, create a test for that specific test case over there. But you know, this guy able to detect it for now. So let's fix that. Well, no, actually. Let me do just that, right? So this is a string array. So with array store, let me put that inside. Right, unshift. So that's that. Right, so it creates an add function for the store. It use provided push. Okay, it can use the provided push function. Okay, it can use the provided unshift function. Right, so these two functions are what the editor provides and it's exported outside. So also let me also change this to that, make sure that they are all exported. So yeah, in case you don't know, you know, that's what I should have done, right? Sometimes I forget about it. Doing it like this, make sure that you are getting, you know, the thing that you're testing, you're actually exporting it, so you won't finish all the tests and then you're so happy and release it and then try to use it. Hey, where's the function? It's not exported. So yeah, this will make sure that doesn't happen. So that's that with array store, and then described with record store. Right, so what is the case over there? What with record store? And what I can do is I don't know, to do something. Right, I'll come back to it a little bit, because over here is also just say what with record store, right? And over here, the reason I was doing it just like that, because I was thinking, well, I already have the function test up there, so it's okay. But it turns out for the record one, I didn't, but I tested over here, which is good. And so yeah. Okay, so with adder, with this is the record and this is the same thing, right? So let me also change this stupid thing. So these put it to the side. Right, again, it is any, I don't care what is in the record right now. I only want to make sure that it is a record. Okay, so that is a problem. How am I going to get that? Because over here at the store level, I only knows about the type T, which is the record of KNT. Is there a way? There's no match. It's unknown. It's the same problem. Right, for registry, I'm able to hack it around and solve it like this. But for the store, what I'm going to do? This guy, I can do it, but the question is this: how do I get the yeah, I think I can. Yeah, I think I can. I will need to have another, and that's probably something that I can add it to. But then let's see if I can find it. So, but the way to do this should be the same. Any, right? And then here is the as. That's that. And then this guy is this. Like that, right? Because the interesting thing is, so you can see that here I get the T because the record type, right? Because the record, well, it's over here. I have it right here. Is the type is actually just that, right? Let me go down into it. So the record type is declared like that. So meaning any P or meaning any property of in K. The K is type of the key of any, which is just the string number and symbol. Any of that, the result type is T. So if I just specify anything over here using the index, the indexer, the indexing in the indexing syntax, then I will able to get the value type because it's homogeneous. It's just T. So with that, now I think this whole thing. What is this? Go away. That's not what I want. So state, well, let's see, first build. That works. Test. That also works. So I think that solves the problem. Right. Of course, it's not done yet. There are still more things need to be done, and I will still need to do some further cleanup. And also, these are kind of horrible. And so what I am going to do for those is create some type alias to make sure that it is easier to understand. Right. So over here, there is this interface. By the way, I am devoted to switch this back to using the type syntax instead of interface. When I was working on the just web, I was experimenting of using interface again instead of type. While in the TypeScript guidelines, I do recommend using type over interface whenever it is possible. And yeah, a very short sidetrack is that the reason for using using type over interface is because the type syntax is more powerful than the interface one, and most of the time that will work fine. The only difference is that in for the interface, because it is not a type alias, the benefit is that when you're using it, it will show it as a single entry. It will not expand it out, and you can see that in TypeScript, right? A lot of the time, the type can get pretty extensive, right, to say the least, right? The language server have to cut this short because it's way too long. It's way too complex. Right, so using the interface have that benefit. However, it's still not as nice as the registry, and I should stick to my gun and just use type. So what you see over here, in the just fun, I was using the interface syntax just for experiment, right? And I can switch it back over here. So back to this. So now I want to make this less painful. So I will export a type saying registry value equal, right? Our extends registry. Any, I don't even really care. Okay, that's it. Did I miss anything? Return type of R. Missing that. What's going on? Okay, so that gets the registry value. Okay, and then another one is registry record value. Well, so if I able to do it like this, I could let x equal to record, spread record. I have all this function and registry array value, promise value. This is all from TypePress already. So I'll probably add a new type alias in TypePress for that. So I don't have to do it over here, right? So but for now, let me export that type record value our extends record any I don't care, which will be equals to our that, right? That will work. So then over here, this becomes a registry value of our. Put it there, right? And then this will be a record value of registry value of R. Okay, let me expand this like that. This I can also just paste this, remove this guy. Okay. Oh, this gets the type of the registry. KT. Okay. And then this, I will just get that to type plus, gets the value type of the record, get the value type T of the record KT. Okay. The actual one I will in type plus, I will probably need to do some more check with different types spreading around and you know that kind of thing. But for now it should work, right? It's just that the testing side need to be a little bit more elaborate. And then I see some error over here. Did I mess up something? Undo this, undo this, undo this. Yeah, this is fine. I think I did mess up something. So this is fine. This is not fine. So what do I get? Entry never. Registry value of R. I do get the record type. I do have to put X over here or something, or yeah. So this got a never type. That's why it needs to be a little bit more elaborate. So our extends record infer K. Let's see if I can just do this. This I still get never. This I getting the problem is not here. So, by the way, that's one of the easy way for you to check your work, right? When you're doing type level programming, just assign it to something constant and then inspect the result, right? So seems like it's not affected by this. So if I say this is 1, never, the error function. For a second, there's something wrong over here. Yeah, this I need to set it to or any. This is working fine. That's quite interesting. So get the return type of that one level is fine. This is not okay. Oh, array value. Hold on. Array value. No. That was wrong. That was wrong. Record value. I was doing something stupid. Didn't really pay attention. So it should be like this, and this should be turn. Should be that. Okay, that's right. Okay. This the type is correct, and this I can do it like that, or I can just say that for now, because this actually, now looking at it, I might mess up, because the if the this works because in my example, the actual code that I'm using, the key is string. So that's why doing this string is good. But it might not be string, right? It's the key of any, which means again, number, string, and symbol. So if there are those cases, this is likely to fail. So I'm going to write some tests for it, so you can see that, you know, the type level programming, you know, you really need a lot of tests. And then I didn't notice my cam is dead again, and well, okay, I'm going to ignore that. And yeah, let's continue. We are almost done. So with that over here, this is a little bit nicer, right? I'm debating, should I combine this alias and create a specific one to make it a little bit easier to extract, but very likely not the case, because I don't really need these types outside of the implementation. So yeah, okay, anyway, so let's continue the refactoring. So this become register value, and this is not that guy anymore, is the return value, record value. That also again not the array, this guy. Okay, so let's run it again. Yep, it works, right? So now this looks good. So let's recap. What have we done over here? So we have, this is still, there is still one more thing need to work on, right? This type of nothing versus with it, I need to make a decision. Should I want to support that, I should say. I want to support that, but can I support that, right? That's will happen when I uncomment this replacer and see if that works. Well, it doesn't take long. If it doesn't, then you know, too bad. Yeah, it doesn't work over here. You can see, right? The expression is not callable. It's the same issue. So for now, at least for this stream, you know, that's where we will end. I would continue to work on that, but again, recap. So we simplified it for now to change it to a single non-overload version, right? Again, the disadvantage is now I have, if I or when I should add comments about what this type is, then I have to accommodate all different kind of overloads instead of having separate different overload, different comments for each overload to make it more concise and easier to read and use, right? So that's the drawback, but is pseudo semi possible, right now we do a shortcut to do it like this, and then we saw the type in the header. I have to infer or extract the actual type out of the type arrow over here instead of trying to rely on TypeScript to infer it. And sometimes the original code, this code, sometimes it will work, as you can see that it used to work in 3.0, right? In 3.0 without the set change, you know, this was inferring correctly, right? So sometimes TypeScript were able to do that correctly for you. Or I really shouldn't use the term correctly, because you know what is correct and what's not, right? It's really depends, and at least it was working in my case, right? Before the change, but after the change, then TypeScript is not able to detect that, resolve that to the way that I want, right? So I have to do something more explicit, which is, okay, forget about, okay, TypeScript, you don't have to help me to infer the KNT. I will try to infer it or extract it out myself. And I am, well, not, I can extract the values using the types, right? Extracting the additional information from the original type, right? We have the get functions. From there we can get the type, or we can actually use the key to do that, use the v to do that, you know, it's the same thing. So that is the way to solve the problem. Alright, so that's it for this video, and I hope you enjoyed this. I hope you learned something, and with that, we will see you next time. Bye bye.